Well, hi, good morning. Thanks so much for coming and joining me here in my shop. Today is November 18th, and I'm in a tough spot with this radio now. So I basically finished all the basic work on it. Except maybe one thing, I haven't done the power supply filter capacitors yet, but that's not much of a concern right now. My fooling around with the radio on the shortwave bands suggests to me it's working fairly well on the shortwave bands. Even though the last video you may have watched has a small section of me listening to shortwave, and it's not very impressive on the video, but honestly, when I was standing here doing it for real, I was pretty happy with the result. But yesterday I did the broadcast band, the AM radio band alignment, and then when I checked the result, try as I may, I could not get this radio to receive very well. This is a tough spot here in my shop for a radio to receive AM broadcast, but this thing should have done much better than it did. So I think. So am I right about that, or am I wrong about that, or just what is the state of affairs with this radio? Is there some deficiency in it that I can find, and presto, it's going to receive a lot better? Or have I really hit its capability considering where it is in my shop here? You know, one option is for me to truck all this out to another location in my house, even out into my garage, just to get away from interference and try it there. Yeah, trucking it is right. That's a lot of work to get it out there and get it set up and find out. But that would bring about a certain amount of certainty, which I don't have right now, which is the big problem. Secondly, the push buttons fail to operate at all. I don't know what's going on there. Could be as simple as these switches are so dirty they're not connecting. Could be that simple. Could be there's some relationship between these two problems. I don't know. Lastly, there was one adjustment I made during the shortwave alignment. A little hard to see it here. This guy right here. This is a variable capacitor, and it's pushed to one of its limits, and even at its limit, there didn't seem to be a peak occurring when I was doing the alignment. Are these all signs of the same thing? Also, up on this antenna is a capacitor designed to, I guess, resonate this coil. And when I adjusted this capacitor, it didn't seem to have any effect. So that's quite a few strikes. Something's got to be out of sorts here. Maybe one of these things, all these things, maybe there's two or three things not quite right. Maybe it's the worst thing. It's two or three things that are running at 75%, which together make 25%, but individually each one is going to seem to be relatively okay. Very, very tricky to find a single problem. Tested the tubes. I remember this one testing good. This is the front end RF tube. Local oscillator appeared to be okay in terms of strength when I checked it with the Sdr radio. That again, that's a qualitative test. It's not a quantitative test, so could have easily been wrong there. Yeah, what to do about this? Or did I make a mistake in the alignment process and I haven't actually aligned the radio correctly? I don't think there's too much chance of that. Part of the alignment is just more or less controlling where the pointer ends up on the front of the radio. More or less. I mean, you can't. So so that adjustment's called the Oscillator Adjustment. You can't push it too far before you kind of get out of the, let's call it the design range of the radio. Or I would be concerned you could get out of the design range. Another very odd thing, and was picking up ham radio signals on the 49 meter band at the top end of that band. How can that happen? The top end of that band. You know, I need to get the glass in here. We can take a look at the glass. I have a photo of it. I'm going to print it. Okay, so I've printed a photograph of the glass plate of the dial. Almost the true size. I just went out and compared it. The actual glass would be just another, maybe an inch wider. So if I just stretch this a little bit, I could practically paste it onto the front of this radio and use it, which is an interesting idea. But it may take a little bit of fiddling to get it exactly right, and you need it to be exactly right to make any real use of it. But first thing it does is it explains to me why, when I went on the 49 meter band, which they don't call the 49 meter band, they call it the B band, and I see why. Because it isn't just the 49 meter band. The 49 meter band is that little piece right there. This is why I was picking up ham radio up here at the top of this band, because it's just above 7 megahertz. This is a ham radio band right in here. And picking up most of the radio signals down here. Well, then I didn't get much of anything down here. Well, of course not. There's nothing down here to get these days except a pile of noise. Although right around 5 megahertz, there's a couple of strong shortwave stations I can regularly pick up down in this area. Okay, so that explains how I got ham radio on the 49 meter band and why all the signals were so crammed here, and I found the tuning so sharp that it was almost unavoidable that you would just go right past the station and never know it's there. So that explains all that. So this is not a spread band. The other bands are all spread out, except this one is semi-spread, I guess you could say. Okay, that explains a lot. Now, as for the radio itself, or the AM band, this doesn't help. But that's one mystery down. So that still remains a few others. How to proceed with this? That's where I'm really stuck. What can I do? And I can do signal tracing. I could trace the signal from the antenna and follow it through the radio, and maybe find a place where the signal appears to get interfered with, or gets weakened, or doesn't get strengthened the way it's supposed to. Could do that. Problem with that is, again, it's all subjective. It's just what I think I'm hearing. The instrument I'm using has its own level and volume controls on it. It's pretty easy to be fooled all the way through, and that's just not, certainty may not be there. Another way is to do signal injection. Push a signal into the front of the radio that I know should be producing a good result, and then look for that good result, maybe in combination with more signal tracing, until the goodness disappears, and then I know, okay, I've crossed the location where there's trouble. That's probably the best approach here. It takes a fair bit of planning ahead to figure out where to test and to find those points under the radio. And then again, in the end, you could just be left scratching your head. Is it good or is it not? I mean, the real be-all and end-all test is a real-world test, not a shop equipment test. That's always been my experience. And comparing it to another radio, another known good radio. So I'm going to think about this a little bit while I drink a bit of coffee and watch BBC Earth, because they're covering Canada. Canada's so big a country that there's always stuff I've never seen before about it. So, okay, I'm going to go do that. Well, here's the idea I've come up with here. Set the signal generator up to generate a regular AM broadcast signal. Tune the radio to that. Hook it up to the antenna here in the normal way. Get the radio all tuned up. Hear how much signal there is. Set the signal generator to produce something out of the speaker that I can hear. And then take it off the antenna move way into the radio here to the grid of the first detector tube or first mixer tube. Get it right on the grid here. Fire that same level of signal into this grid. And here, what happens? What I would expect to happen is it would be not as loud, I think. I'm thinking about the effect of this tube. It's yeah. I don't even know what to expect. If this tube wasn't here, then you would expect the antenna signal to be depleted going through coils and whatnot before it got to here. So hooking up straight to this grid would give you a bit of a stronger signal. A bit. This tube here, it's playing an important role. I'm not so sure it's amplifying the signal as such. So another possibility is, of course, to put the signal in on this grid, which is getting you closer and closer to the antenna. So we can try this. Maybe I should not think about it too much. I should just do it, and then think about the results instead of imagining what the results might be. I'm not terribly familiar with doing this kind of stuff, other than poking around here and there. But trying to get quantitative type results out of these tests on just an amateur bench like what I have here is pretty challenging. But what else can I try? I think this is probably the best move. So set up on the antenna, get things going, try the grids on the first two tubes, see what happens. Okay, I think we're all set for test number 1. So despite all the 8s on here, I do have this signal generator set to 1 million, middle of the broadcast band. And we just do this. So you hear it on the radio here. Treble tune. Okay, the signal generator is connected to the antenna input. That's the strongest signal I can produce out of that doing this. So it's already showing evidence of weakness. I'm going down 1 setting. Okay. I think we'll do our test there. Let me tune again. Okay. Now I want to move the input around. The first tube here is just inaccessible through here, so I put a tube extender on it, that brown thing, and then all the tube terminals are exposed. And I can move the input of the signal generator, but I think I need to protect it with a capacitor. I feel the need, so I'd like to pick a smallish one here. Let's try this. First we'll okay, got the same result there. So now I'm going to stick this on the grid. This is a really problematic test, but I'm going to go ahead with it. I'm going to stick it on the grid of the first tube here. Same signal strength, which is very high. It's very high. Let me check that. How high is very high? Is that, am I kidding myself? So this meter, to calibrate this unit, needs to be right up at the top here. Now the unit's calibrated, so I know what is coming out of it. And what is coming out of it? 1,000 times 10. 10,000 microvolts. 10,000 microvolts, that's a very strong signal. 10,000 microvolts. Is that really what's right at the end of this wire? Well, maybe not. Maybe it's a little different because of impedance stuff going on, but it's certainly in that range. So hooking back up again, starting with the antenna spot. the modulation off. Modulation is 30%. Okay, so you can still hear the noise in the background. There we go. Wow. Tell me that's not better. Now that's really what it should sound like when I have it here. We've already found where the signal is disappearing. There's no need to do the next tube. Okay, that's good. That's pretty convincing. Somewhere between this antenna terminal and the rest of the radio, the signal's not making it. Now, it is kind of an odd thing how they have this arranged, to me anyway, but I guess they wanted to make the wire antenna available for broadcast purposes if for some reason the loop wasn't doing the job. The loop is not really a long-range antenna, although it seems to me they work fine. Maybe a big wire in your backyard is actually better in some cases, especially back in the 1940s. Not so much today, because of all the noise. Wires pick up a lot of noise. Okay, so we're looking now for where does the signal disappear. So I need to work my way back from the grid of this tube to the antenna, injecting a signal each step of the way until I cross the bad guy. So we got to look at that schematic again here. Okay, where are you, bad guy? So what I did was I injected a signal into this right here, and it came out beautifully. So how does it get there? It gets there. All signals come through here, this capacitor. So this is a possibility. So I need to get on the other side of this capacitor. So I need to trace from the grid. This is really tough in this radio. Back until I find this guy. Oh, you know what? There's a diagram. It'll show me where it is. C6. That's right. Yes, fantastic. Looking for C6. Where are we here on this? C6. Here's C7. C5. I always find them like that. I never find that. There it is. C6. I did find it. So C6 is from right on the grid of the tube. This is right the same grid I just tested on the underneath to this terminal here. Okay, so all I gotta or follow the green wire and pump the signal in here. It's going to be easier here to know for sure I'm hitting the right spot. So right in there, eh? Okay, let's go back to the radio. Right in there, he said. Right in there is a pretty tough spot. Right in there. Let's just get this kind of set up a little bit. Right in there. There's a big green wire. That's not the right one though. Oh my gosh. You can't even see up in there. So pin number 4 is up in this area. Behind the coil. And there's a green wire. A green, well, it's supposed to be green. There, you know what? There's a capacitor back there. There's a capacitor hidden right behind this coil. And that capacitor comes to the terminal strip. I can see the terminal strip. Bingo. That's really what we want to get to. Okay. Feeding the signal in on the so we want to go on either side of the capacitor. It shouldn't sound any different. Can I stick this all the way in there? Can I? Yes, I certainly can. The wire that goes to the switch is a short bare wire. So this will be on the other side of that capacitor. How come I don't hear a thing? So I hear the AVC quieting the radio completely here. So I don't think it's that capacitor. So if you go back on the antenna, see it's weak. Weak on the antenna, but not weak on the other side of that capacitor. Okay, you have to go back to the schematic and figure out what's next. Okay, so we made it, where are you here? Oh, I'm looking at the wrong diagram. We made it past this capacitor. Oh no, we go into the switch here. Yikes. Well, I'm going to have to analyze these switches very carefully here too. I mean, there's a way of deducing them by looking at the coils and the wires. And the other way is to actually study the way they've drawn the switch very carefully and reason out as you turn the switch what is hooked up to what. You know, on the broadcast band, actually on all bands, the antenna signal comes in on, well, we don't know that. I was going to say it comes in on this black wire. But we really don't know that for sure. It could be coming in on this green wire. Oh my gosh, let's take a look. Maybe we can sort it out here. So they're showing the switch rotation, and I'm pretty sure the switch is in the broadcast position. Somewhere there's a note. Somewhere there's a note. Didn't they put a note on here? Somewhere I would hope there's a note. Range switches are shown in maximum counterclockwise position and viewed from front of chassis. So the range switch is what I call the band switch. Are shown in maximum counterclockwise position. Maximum counterclockwise position of the range switch is in the push button position. It's not in the broadcast position. Phooey. Okay, so we have to do a little bit of reasoning here and imagining. So what these two switches are doing is they're selecting individual or combinations of these coils and these capacitors here and there to achieve the kind of resonance that the designers were looking for. And you see here it says through connection. This dotted line really indicates that this point and this point are electrically common. That's my understanding of it. If you look at the switch, this one's a little clearer to look at. It has a bump out here, it has this bump here, and then it has this long contact. Something is always maintaining contact, and that would be, I think, this one. So this is on the way out. So it's always in contact with the slider. In the position it's in right now, oh help me, it's in the push button position. We want to snap this once in the direction of the little arrow there. So we disconnect from here. This is probably going all the way over those buttons. Yeah. So you're disconnecting from the push buttons and you're connecting into broadcast mode. You're connecting this capacitor, and these are the tuning and trimming capacitors. This is the actual big capacitor you're tuning here, but you're clicking in this one. So you snap it once, and you've also joined. You've joined these two with this thing. That's what it looks like. Why would you want to join these? Don't you want to walk away from the push buttons? Oh, going the wrong way. We're going the wrong way. We're moving the switch the wrong way, Jim. So if we snap it once, so how did I manage to look at the arrow and then start thinking the other way around? It's because all these contacts are very inviting, I think. Okay, so this guy goes one snap that away. We have these two capacitors connected, and that's all. Just these two, nothing more. So that's not in the circuit. This is in the circuit, but we tested it. This is not in the circuit. Now we'll go down because this is connected through here. We analyze this one. So somewhere we have an A band. Where's the A band? We have a B and a B. Well, the A maybe is this. I don't know. Let's continue on here. So we're coming down. The switch looks kind of similar in a way. Which is the always in contact piece? Looks like this piece. That's coming out the bottom of the antenna. This is always in contact. In this position, it's contacting this B. Primary may not matter. There's a ground right here. Yeah, so it looks like a ground is stuck on here and stuck on here. That's what it looks like. You snap it once, you release the ground from this one. But look, it's a shortwave band. I don't think it matters. And you engage this one. No, this one's always engaged. Always engaged. So we're gonna move. Gotta look at this. In this position right now, this one is engaged. So that's the antenna. Okay, whatever. I don't know what to make about that because we don't really care because we're going to snap the switch once. This will move to here. Now we're engaging B. We don't want to engage B. We want to engage A. Where's A? A band. I hate these switches. Okay, continuing on here as best we can. For some reason this is engaged. I'm getting quiet. So we know that in the broadcast position, this wire is connected to. Well, actually, in this position, this wire is grounded out through that ground. In the next position, it's still grounded. So this signal path does not appear to be used. So the other signal paths from the antenna, the only other way out of here is on this wire, C wire. So we follow the C wire. It's colored green, which is interesting because green often means grid signals, grid level signals, green wires. So it's over here. Am I misinterpreting what is going on there? I don't think so. I think it's the same as this. It's just drawn so it looks a little questionable. So we snap the switch once. This guy's no longer connected to anything. Well, no wonder it doesn't work. There's no antenna connected. That's what the problem is. Maybe this number one comes all the way. See, up here, they were able to draw the arrow all the way to the ground part here, because the nubbin is off to the side, but here the nubbin is right in the way. So I think what they did was they tried to draw a hollow nubbin with an arrow inside to indicate this guy is coming all the way over. Let's assume he does. This guy comes all the way over, always in contact. You throw the snap once, you've hooked up to this wire. B. What is going on? That doesn't make any sense. Where's A? Where are you, A? So that would be A. Snap it again. Now you would drop the ground here, would be free off of here. B primary would be doing something. Primary and secondary. I would say B primary, but they never say B secondary. Like, the guys who did this, they must have been laughing, going, "Oh, this will really throw them off the track." Just rub out that word secondary there. Why wouldn't they write secondary? Why would they write primary here? Because the primary is being driven by the antenna, and the secondary is trying to drive the grid. Wouldn't that be how this would be arranged? If we were on band B, this would somehow make it to the grid. So let's follow back from the grid again. Grid up this way, into this godforsaken switch. Snap twice now. Click, click. Still hooked up here. Doesn't it always have to be hooked up here? All the time you need these in the circuit? Isn't that the way it would work? Is it possible it's not the way it works? You know, it's possible that in a spread band radio, you really don't need a tuned front end, like a variable tuned front end, because the front end can be fixed tuned and cover the whole spread band. So you would need it on this radio. There's two bands that are not spread, three actually, not spread. A band, B band, and 16 to 13. 16 to 13 is here. Here's another one labeled primary. So this must be the primary for the B band anyway. Maybe it's the primary for all this. It'd make a lot of sense to me how it could work on this frequency and work at that frequency too. So again, maybe this coil is hooked up to the antenna basically. The antenna is driving this coil. That's the entire antenna circuit right here, just right there to ground. And then this primary is driving this coil, which is tapped. And you're selecting different taps as you select the different bands, and bringing in more and more coil or less and less, whatever the case might be. And in some cases, you're not snapping in this at all. You're bringing in this. This is only good for one band because the little nubbin can only touch one of these at a time. So 19, 25, 31. Next would be 30, 31. What's next? What's next on here? Okay, because I don't want to make a mistake. 31B is next. So in band B, this is in place. And one more band A. Well, this is the pass-through that we've already tested. Am I getting this figured out, or am I not? So if we want to trace the signal from the grid to the antenna through the stuff for band A setting, we would make it through to here. We would make it onto this rotating thing. The rotating thing would be pointing at 2. We're making no contact with any of this. No contact with any of this. Instead, this piece is contacting here. So in band, the reason there's no A down here is there is no A down here. There's no A. This might be A, right here. Kind of weird because this is not tunable. And the broadcast band, it starts out at 500, ends up at 1500. That's a 3 times frequency change. If you think about the short wave bands, the frequency change is a small percentage of the overall frequency. So this is a big deal trying to tune a radio across the broadcast band as compared to short wave bands, especially band spread short wave bands. Okay, I feel like I'm getting somewhere. I'm just not getting all the way there yet. Are we there yet? No. So meanwhile on the so how does, if none of these are involved, the antenna signal has to get, it must come through here. Okay, so that's the idea. So the antenna signal is coming through here on band A. So with this snap to 1, what is touching this? 2. No, can't be. There's the arrow for rotation. I'm not interpreting this correctly. In this position right now, this is going, this is going to the antenna. This is lovely. This is just what we would want, kind of. In this position, the antenna is connected through. Yeah. So that's right. So this arrow comes all the way and is always in contact with this. So 1 is always in contact with this all the time until you turn this a couple of steps. So this would be push button, then you snap at 1. You're on band A. I think if you snap this one over, then this is in contact. I don't understand that. But you still have this. Maybe this is immaterial for some reason. No, it can't be, because yeah, maybe it is. Because then if you snap at another step, now it's down here on 3. Oh, this is 3, not 2. This is on 3. Okay, so you snap this one step, nothing happens. This remains connected. C is the output from the antenna during broadcast, when you're using it in broadcast. So we need to know these switches are working. We need to inject a signal at C. So the next step back from here is C. Okay, C is here. Green wire up onto switch, the first switch. Switch or coil? S1, that's a switch. Green wire, well, I see stuff in there. So we have to trace. Where are we tracing from now? We either got to identify this. Yeah, that's going to be a little tricky. Very hard to look at this diagram, but I think this is the chassis. This outer line here, I believe, is the chassis. They've dotted it here because it's not an edge, it's a fold. So you can picture this part. This is the apron folding up, this part folding up, and then they're continuous. It turns into like a box. So okay, so that's what's happening down here. That's what this line is. So that puts this number 1 way at the bottom of this switch. I'm going to look in the radio just for a minute. And you know what? There's a green wire right coming to that position. I can see it. We're going after it. Okay, so the green wire, so that's the switch we're talking about right there. The green wire. Is right at the end of my pencil. You can see it in the camera there. That's where we got to make contact. To get down in there, I need a thing. Okay, so what I've done is I've simply taken a voltmeter probe and attached it. I still have that little capacitor in there. We will go up and touch that grid to start with. Where's the... Why didn't we hear that? Because I just turned down. Why are we hearing no modulation? What happened? What's happened here? We should be hearing a 400 hertz tone. What has happened here? What did I do? Did I do something? Did I change the band? I did. What goes on there? Oh, when did I do that? Okay, there we are. Hear it? Let's go a little louder. Okay, so now we're going to try to touch the other. So that's at the grid. Wow. That's at the grid, and then I can't remember what I did on the next one, for crying out loud. I found an easy way of doing it, didn't I? Let's just go with the one I'm aiming for now. Okay, so that is very tricky. There it is. Oh, sounds good to me. Well, you know what that leaves? That leaves the antenna to be a problem. I think that means the antenna's not doing its job. Let's look again. So we touched here. I actually touched this location here. And it sounded great. Now, we have to figure out what's going on. Maybe the switch is a problem. Pin number 1 on the switch. So we'll go back up here. Pin number 1 on the switch. Is this where I am? Is this where I am? I didn't do that, did I? So this is called S1 front. This is called S1 rear. Okay, so S1 rear is what I was touching. So I'm touching S1 rear, right here, which would be the same as C. Just right up from here, it's those 3 wires I installed up to the antenna. Let's just see what we can. If I left those wires open a bit, but they're not. I've insulated them. Wow. So what spots are there on the antenna that I can touch? That capacitor. This capacitor is actually exposed right on the top. So I could touch one side of this capacitor. It should be the same thing as touching here. And then the other side would be probably where you don't hear it. Okay, good. tunable capacitor on the antenna itself. Okay, we gotta look up for this. Okay, get my signal. Check to make sure nothing has changed. Touch where the green wire is. There it is. Now, up here. Good. Nobody home on the other side. Nobody home on the other side, so let's take a look at what that means. So now we're over on this side. I have to think hard about this. We have this capacity antenna which I cut away. It was just a bundle of wire when it came in here, but this does something, I don't know what. Can't be doing much though. Can't be part of this picture. I don't think, or does it, or is it? Capacity antenna lead. Is it? Could they have said capacitor antenna lead? Is this thing supposed to be a capacitor? Into space? Big long hunk of wire? In a lot of these radios, this wire is wrapped around a card about half the size of a shoebox lid or so. And then it's tucked up above the chassis in some cabinet slots that are made for it. And it sits up there. It's just like a coil, maybe 10 turns of that wire. And it just sits up there. And it's called the capacity antenna. Is that what this whole problem is? There's some capacity missing here? I used to have a CB antenna, and I had a CB radio and an antenna. I had both. And a microphone too, when I was in high school. And the antenna I had was called a CLR2. Clear 2. It's a great big tall antenna my parents foolishly allowed me to put on our TV mast. We had a TV tower with a TV antenna on it. God knows how I did it. Oh man, I had to climb to the top of that tower, loosen off the U-bolts and slide the TV antennas down. I won't go into it. Let's just say I risked my life putting that antenna up there. My parents came home, they were freaked out. They didn't realize what they were permitting me to do. They went off to the golf course and I quickly put it up there. The top of that antenna, the reason I'm telling you this, the top of that antenna is basically a whip, but at the very top are 3 little pieces of wire sticking out in the three cardinal directions. You can't really say that, there's 4, but I think you know what I mean. And that was called the capacity hat, or the capacitance hat, is what it was called. So I think you're adding capacitance at the very end of the antenna. I don't really know. It's a curious thing to me. When I used to broadcast with my little CB radio, the people who lived across the street could hear me on their cheap little electronic organ. So when you'd be playing the organ, all of a sudden my voice would come out, breaker, breaker. Yeah, funny situation. So, okay, so we have no signal here. You know what, I can start now. I can turn off the radio and we can feed a signal in, on this wire and try to trace it through to the side. What if this capacitor is just completely open? Well, you have this coil. And if it's shorted, well, that's good. The signal will come right through it. Very mysterious. But that's the thing. I can turn off the radio and we can continue just testing basically on the antenna circuit now. From here out to there. What if something funny's happening on this wire? So if you snap this once to the broadcast band, this wire is connected to ground. It's grounded out. So they have a ground. So this capacity antenna thing can't be doing much. There's a ground sitting right here. Well, if you have a ground here, you're not going to get any signal from up here faster. You can't get any signal in on this antenna wire. So maybe I've been wrong this whole time the way I've been doing this. That when you flip to AM broadcast band, a ground is placed right here, and that, well, you know what I would do? So I would leave the antenna signal energizing this coil, and this thing might be resonant to some degree because of the capacitor here. So this thing's humming away, humming away. Got the 590 sports channel just humming away on this. And then the idea is for this to influence this. Now this coil picks up what is screening on this one, is tuned one time with this to make it resonant, and then that's what's feeding into the radio. That's how they've done it. That's exactly how they've done it. So me feeding a signal in here, I shouldn't be surprised if it doesn't. Well, I should be surprised because it's still going through this coil, still meeting up with whatever resonance is here, still energizing this outer coil, probably very high impedance here, firing it in, essentially straight to the grid through this capacitor. Problem seems to be right in here. That's what I need to test the daylights out of this antenna and come to some conclusion about it. So what if you don't have a wire hooked up at all? How are you going to special? Hello, English. How are you supposed to get a good signal? So in that case, you might be relying on this larger winding here. And that's it. This guy is just doing nothing now. He's not energized by anything. He's hooked up to a ground. So this guy's out of the picture. So this is nothing more than how you get, in broadcast, how you get an additional signal from the antenna. What's the word? You impress it upon this outer coil. This is out of the picture because you're not using it. This is it. This is the coil. This is the resonance. Open wire somewhere in this coil. Why would you have an open wire in this coil? It's all safely protected, isn't it? I can see, well, I see what looks like broken wires. Holy smokes. Are you serious? Yeah, let's take a look here. Broken wires. Really? This is what the investigation is going to come down to. I noticed this earlier and decided it was probably just cloth. And there's another one down here. It just seems to come, you can't really see it here. It's there. That one doesn't worry me too much. We don't know what coil's what in here. We don't know what's inside here. This could be the coil that they're showing in the diagram inside the other coil. In fact, it could be physically outside. And the main antenna coil could be inside here. So is that really a broken wire there? Where's the rest of it? How would that ever get broken up there? I gotta pull on it or poke it or something. Maybe it's, sometimes the cloth kind of comes free on these wires, and it looks like a wire when well, it's not behaving like a piece of wire, is it? say. So here's another spot here. I'm just going to lift up the camera. There's another one right here. At some point there has to be wires coming off this outer coil. They could be hidden in behind here. Any one of these. Or they could be visible. There should be two wires. Somewhere it has to come off. So this is pretty clearly looks like one. This looks like the other one. But, sorry on the camera work. Looks like I'm going to have to take that thing apart. It's all riveted together. It's stapled here. I can pick those apart. These are rivets here. And this top part, the bracket is screwed in. I can release the bracket easy enough. To pick all these, I got to do some testing and find out what's going on before I do that, because that could be another disaster in the making. Well, it would be interesting to see inside there. Coffee time. Okay, I think the first thing to do is give a careful inspection, especially where I see the wires coming off that loop. So we'll use the other camera here and just kind of start with the capacitor. Oh, I hadn't really noticed that. So this rivet and this rivet, I don't know. I don't think these are electrical. I think, well, maybe that's not true. So at a glance, you'd think this thing is hooked up to this wire, but they're not. They just share a hole. And this terminal is coming up out of a hole there, isn't it? What is going on there? Certainly something coming up out of the hole, connecting to this rivet terminal. So I'm going to take a guess at this point that this terminal goes nowhere. That this rivet doesn't actually go anywhere electrically. It's simply a physical place to put a terminal to connect an internal wire that's inside the antenna to the external wire. This is the capacitance hat wire. Look at the green patina on there. The wire I cut off. Very clumsy soldering job there. So I think all that is, it's just like a strain relief terminal, but we can find out later. I think the two electrical terminals are, this rivet and the other rivet over there. I believe those would be the terminals. You can see the mica sheet that's in between. You can see the top plate and the lower plate and the mica sheet in between. Don't see anything unusual about any of that. Let's go around the racetrack. Well, first here, let's just look at my own work here. So that green part is the original wire, and then I have a connection to this lovely green wire. I've done the same thing in each place. The connection is just up here a little bit. And this one would be the one that these were actually quite flexible right close to the antenna. So I don't think the insulation's broken. It's not shorting out or something like that. Okay, let's go to the racetrack. Here we go. Just starting in a random spot here. What do we see? Tape. Some paper in there. I don't think it's important. Carrying on. So there, now that very clearly is one wire coming off. Now you'd think the other wire would be on the outside. The other end of it would be on the outside. Somewhere, typically it would be right around here. It'd be maybe under in here somewhere. Usually they come off at the same place, but not necessarily. So you know what? The outer wire comes off the outside. It has to get into the inside because the goods are inside here. So let's keep going. We'll find that outer wire, which could be hidden. Where are you, outer wire? This is the wire I saw earlier. We're almost all the way around. I just come to here, that's all the way around. So there's only one spot where there's any wire sticking out, and that's right down in here. But oh, I think I know what's going on here. Notice there's some Scotch tape here too. This wire on the outside, and I have a lot of trouble managing my camera. This way. This is the way we would see it. Where this tape is, they may have like pulled the wire off and then applied tape to stop it from carrying on, to strengthen it so if you tug on the wire it doesn't peel away. So this is almost certainly the outside wire. Outside wire, and there it disappears inside. So we've seen both wires disappearing inside. Far apart. They're at opposite corners of this thing. This is the RCA Victor Magic loop antenna. Highly efficient. Dedicated for finer reception. Dedicated? Designed for finer reception. Better than a wire is what they really want to say. There's the, you can't see him, but there's the dog. I think the dog listening. And he's worn out. RCA. These radios were competing on these antennas. And so they needed to look kind of fancy, and there's definitely some pretty fancy versions of these things. Big box, big boxes, not flat like this. So I do have these terminals to test, and I have the terminals on the capacitor to test, and I have this connection to look at. Somewhere between here I should be able to look for continuity and not find it, and then deduce that there must be a break in the wire inside. How would it ever break inside there? Somebody tugging really hard on one of these. You'd think if it broke that way, it would come right out. Stand up there, will you? Okay, going to study the schematic for a bit and come up with a approach for testing this that might reveal a problem inside. Okay, let's see what we can figure out here for testing. So I've identified these guys in terms of A, B, and C. A little diagram down here. Actually not the easiest thing to figure out. A, B in the middle, C. So we look on the schematic now, and we see between A and B, we're going through a coil and a capacitor, and nothing else. plus. So let's take a look at that between A and B. So we should see the resistance of that coil. It's an unknown resistance, but I expect it to be pretty small. So watching that ohm meter, there it goes, 50 ohms. Okay, so that makes sense. So A to B, so the coil inside is good. Now if we want to test that outside coil, we would go from C to B. C to B should test the outside coil. That's pretty easy stuff. So C to B. So we go on B. Get on there. B only. B and C. Son of a gun. It's pretty much a dead short. So that was C to B. Pretty much a dead short. Well, yeah, it could look like that. 2000 ohm scale. What happens if you test C to A? So C to A, you should see, and you're going through both coils at that point. C to A. $50 ohms again. So this is not revealing anything. Okay, test across the capacitor, and we are testing the bigger coil across the capacitor. See how low it got there at one point? Just bad connection, so like right down to 0. And that was across the capacitor. That's testing definitely through the coil. So if there's a short in C2, C2 is shorted. Let's just make this 200 ohm scale. 1.9. Open this up. Should have the ohm meter connected to it while I do that. 1.9 again. I don't think that is shorted. The other capacitor was shorted. So unlikely, except the other circuit, the center one with the capacitor and the coil, that's hooked up to an outdoor antenna. Outdoor antennas can be affected by lightning. A lightning strike. It's not very likely at all. Not likely at all. I'm not finding anything wrong with this antenna. Still curious about this thing. How does this happen? The inside takeoff point is way over here. At least that's what it looks like. What's going on with this? But you'd think if this were broken, then that would make this coil open. Which coil is that? We have to guess it's the outside coil. Then how could I have done this test and get anything other than an open? If that wire's broken there, that would open up the look at the way they've got that labeled there. L1 loop assembly. Look where the arrow's pointing. L1 loop assembly. I don't have any other label. It's pointing inside there. Why didn't they point it just to the outer edge of the outer coil? Are they trying to say something there? L1. Well, there's two coils. There's the inside coil and the outside coil. They deserve names. They've named the inside one L1. They didn't name the outside one. Maybe because they don't think of it as a coil so much as an antenna. So you can't call it L anything because it's not in their minds. So they would call it antenna. Now down at the bottom they say capacity antenna lead. So they named that. They didn't really name that coil. And you think the way they're picturing it, one coil inside the other would be the way it's built here. There's something inside here. There's a pretty hefty dimension here. But I could be completely wrong, and this could be L1. How would I tell them apart? How could you tell them apart? So the end wires disappear inside, and we don't really know for sure what's happening in there. This is not revealing any problem here, except for this. We got to investigate this situation here. So they'd wind this. When they're done, they have the two end wires. They then put some Scotch tape, or whatever it was called back then. I don't know if it was Scotch tape. Now wait a minute. The takeoff is here and there's no tape. There's tape here. The other takeoff is here and there's tape. There's no tape here. No tape here. Something really weird going on. I have to take this thing apart. I don't want to take it apart. I'm going to destroy these rivets. Will be destroyed. Although, you know, I could take that off, pop all these staples out, and then just bend it open. Leave this like that. Just bend this open a bit. I have no idea what's inside, how it's held. Like, how is anything even held in there? There's no riveting out here. Nothing on here. So how's it held in there? Maybe they produced this antenna and it was flat, and the marketing guys came down and go, look, you know, our competitors have this big box antenna in the back of their radio. People look at it and go, wow, there must be a lot of stuff inside. And you're showing us this thin thing. They're going to say there's nothing inside there. Okay, well, we'll just fatten it up here. Then they'll go, yeah, see, the goods are inside there. I don't know. Yep, time to stop and just think a little bit. Okay, got another test in mind. So one of the keys here to getting a signal on the broadcast band to come from a wire antenna is for it to get in that internal coil and then get impressed on the external coil, the outside coil. The internal coil will do that if a ground appears at B, which is what this switch is supposed to do. C8, the switch S1 rear should apply ground to right where you see the capacity antenna lead. What if it's not? What if it doesn't put a ground there? Well, then feeding a signal in at A is not going to do much, I think. Not much at all. So is there a ground at B? B is attached to where the capacity antenna is. That's this. So I'm going to plug this back in the radio and check for a ground there. Is this going to reach? Check for a ground when the radio is switched. I can't see at all what I'm doing. Oh, for crying out loud. I can't see a thing. Cannot see a thing. In you go. Okay. So we're going to monitor for a ground. At the capacitance antenna. When the radio is switched to B. That's not B, A. That's where it is now. There's the ground. Let me wiggle the band switch a bit here. So that's push button, broadcast band, band B. Then shortwave bands. These must be coil resistances I'm seeing. Let me go to them. That's the today 0 is 0.3, 0.2. Okay, well that's not the problem. The ground goes in place. So if the ground goes in place, what the hell else? Excuse me. What the heck else can be wrong here? Plugging it in and the wires I installed didn't work. They certainly look like they're soldered into the plug. Maybe this is not working right here. So I could be able to go right from the antenna, oops, right through this coil, all the way to this point B. Let's try that. Okay, so all the way from the antenna through the coil. There's that 50 ohms again. Oh, everything is testing out fine. But it's not fine. Okay, I think I'm going to come up with a whole different approach here. Something crazy. I feel like doing something crazy at this point. Okay, so I think what I want to try to do is pass a sweep signal through the L1 center coil between points B and A, and energize that coil, and then see what is happening on the outer coil, and look at it using my SDR. See if we can see a resonance and all this kind of stuff. But first, I've noticed that B, down at the bottom there, B connects directly to the capacitance hat. B is the center terminal on the connector. That's this one. And very cleverly I used exactly the same wire for them all. And it goes right down the hole where the B terminal is. Why wouldn't they have connected this wire straight to this terminal? Why go inside and make a connection? I don't quite understand why they would have done that. You'd think they're going in through the same opening here. They probably are connected inside, or they would have made 4 openings here. You might think that. So that means that, what does that mean? That means there's something curious going on here we don't quite understand. According to the schematic, it's nothing curious. Okay, fair enough. Okay, enough of that. I'm going to get my sweep generator going and we're going to see what we can see here. Okay, this is a little bit of a lunatic type test, but here we go. So what I've got happening here is I'm going to feed a sweep signal into the wire antenna coil, if I can call it that, the coil that I think is inside here. and the signal is going to sweep from the bottom of the broadcast band to the top, so from like 500 to 1600, something like that. As it sweeps up, it should encounter, I guess, some amount of resonance in the outer coil. I'm going to try to see that resonance on the Sdr you're looking at in the top right corner. This is the Sdr Pickup Coil. That's going to that's the antenna lead there. It's just clamped on together. It's crazy. This is a crazy thing. I plan to adjust this capacitor and see if we can see anything happening. This is my scheme here. So first, I'm going to raise up the output of the signal generator here, and if you watch on the Sdr, you should see a plateau come up right through the broadcast band. So let's do that. Okay, so there's a plateau. Pretty easy to see. Well, I don't see any evidence of any kind of peak in there at all. This is a terrible, the Sdr is not great at doing these kinds of things, but it's what I've got. So we're going to try now and adjust this and see if we see anything happening. This was open a fair bit. I don't really know what to expect. And we're sweeping through a fairly large range of frequencies. So getting a peak should have, oh, there it is out on the right where the noise is. Just using noise. I don't even need a sweep. Don't even need a sweep. Well, this is answering the question. Let me turn this off. Where'd it go? How come I can't see it now? No, it's still there. Still there. I could tighten this capacitor right down, and that peak doesn't make it into the AM band. We need more capacitance here. Is that because I've done this? Or I have this out and it's laying up against a big metal radio? The radio's not on, by the way, it's just sitting here. Well, let's move it around and find out. Let me drive the peak. Let me turn this back on because I kind of like that. For some reason it increases the peak visible. There, turn this in as far as we can get it within reason. I don't want to go any tighter than that. Okay, I'll move this thing around. Let's move the whole antenna around first. So it did move it a little bit, didn't it? Just quelled the lower end of it. Okay, now maybe where I put this antenna is throwing it all off, so we'll put this back here. Now this is going to change a lot if I move this. Doesn't seem to change that resonant point. It's still I'm getting close to the signal source. Is that what's happening? Don't think so. I think what we've got here is a case of the antenna is not resonating at the right frequency. It's resonating way high. There he goes, off to the right. Now, this wasn't the craziest test. Now what can be throwing this way off? First, the antenna is not plugged in the radio. This is hanging open. So there's some more radio stuff that's not on this antenna. I got to repeat this with this in the radio. This is terminal A, correct? So I'm going to have to get this onto terminal A in the radio. Let me plug this in. If I can get it there. So to me, this is where the fun is in doing this work, doing this kind of stuff. Being on the edge of your understanding of what's going on. Trying this, trying that. Sucking back the tears. Okay, that's in. Now I gotta get on to terminal A. Terminal A. It's gonna take me a minute. Well, let's just leave it running here. Terminal A. Terminal A. Somebody show me a schematic. Terminal A. So terminal A. Wow, I have to get right up. Right up. No, terminal A is the antenna. So I should be able to go on terminal A and up here and see the same effect. Because I'm putting the signal between A and B. B is grounded, but that shouldn't matter. So what did I got so excited about how, oh yeah, onto the antenna here. Okay, we should see exactly the same thing. Oh my gosh, look at the difference there. Jimmy. Okay, now we'll tune this. That's got a heck of a peak on it. Well, this isn't changing. What's happening? Why does it look like that? Yeah, it is moving, isn't it? You see how it's basically sitting in the center of the band. I would prefer it to be, if anywhere, if this is a true thing, way down around the 600 mark. Could be that this antenna is working great at frequencies where there's nothing to receive here in my location, nothing strong. The strong stuff is down where the antenna is not so great. Look at how sharp that peak is. Hey, what happens if I tune the radio? It's going to move it around. It's going to move it around. Hot diggity talk. Okay, something interesting here. I'm not sure if I'm interpreting it right, but let's just keep making observations. I'm going to leave the thinking for later. I'll dial this down to where, yeah, look at that. So we're looking here a little lower. So that would be around 700, somewhere around there. You know what? I've got a guide. Here. Okay, you know, I'm running all around my house looking for a piece of paper I think I never printed. All I had to do was this. Look up here for 600 kilocycles, 33 degrees. So we'll set the radio to 33 degrees, and then we'll check and see if the antenna is resonant around 600. That would be the plan. Okay. Oh, so we have to switch to this guy, I think. 33. So I don't need to be too precise here. I will just do this by my own eye. This would be roughly 33. My pointer is completely out of whack. So that's 33. What do we see? It's dead on 600. The tuning is dead on 600. Maybe a little hard to read on your screen, but I can see it. Let's just move this around for fun. It's not moving. So I'm at the low end, and I bet you this doesn't have much effect at the low end. That's probably the deal. Okay, so let's go up to the high end, because it is a capacitor. Okay, so we're up around 1600 or something like that. Let's see, the antenna currently is tuned to about 1350. And this is where things got a little tricky. Oh, no, I've got guidance. Jim, you've got guidance. So 1400 is 155. Okay, 1400 is 155. 1400 is 155. So we'll look on here. Just about exactly where I had it. There's 155 there. And this thing is resonant at 1320 or so. When it should be resonant at, what did I say? I said 1400, didn't I? So we'll adjust this. There it goes. Tune it up around 1400. Okay. Well, that solves pretty much solves. Yeah, it doesn't solve anything, does it? It leaves the mystery of the weak AM still there. The mystery continues. I think that's it for today. Learned a lot of stuff. Had lots of fun. Didn't actually get the result I'm after, though. But, time for lunch. Thanks a lot for watching, and tomorrow we'll just carry on and try to figure out if there isn't something about this radio that's making it unnecessarily weak on the AM band.